Okay, this is AP Calculus practice test from 2018. Multiple choice, starting with number 76. We'll go through about number 82 or so on this video. So we're given a video of a graph of f prime, a graph of the derivative, and the question asks which interval is f, the original function, increasing. So f is increasing where f prime is greater than 0. Okay? F prime is greater than 0. If you remember from when we did sine lines, and we'd have some sort of critical point, when the derivative was positive, the function was increasing. Okay, so let's look at the options that were given. A says from -3 to -1. Well, from -3 to -1, f prime is less than 0, so it's actually decreasing. F is decreasing. Let's look at option B, from -1 to 3. Well, from -1 to 3, it is greater than 0. F prime is greater than 0. So B is the answer. F is increasing. Let's look at the other two just for the heck of it. Part C says -2 to 0 and 2 to 3. Well, 2 to 3 it's increasing, but at -2 it's still below 0. The function is below 0. So from -2 to -1, f prime is less than 0. So that's no good. And then part D says from -3 to -1. Well, that's below 0. And then 1 to 3. 1 to 3 would be true. But from -3 to -1, f prime is less than 0. So it's going to be decreasing from here to here. So the only option that is true for everything is B. All right, that's a good one. That's one you can get really fast. You don't even have to plug anything into your calculator. All right. Look at 77. So 77 says the rate at which water leaks from a tank in gallons per hour is modeled by R, a differentiable function of the number of hours after the leak is discovered. Which of the following is the best interpretation of R prime of 3? Right? R prime of 3. Well, I can tell you R prime of 3 is going to be a rate of change at t equals 3. So we need to see which one of the options is telling us that. So option A says the amount of water in gallons that has leaked out of the tank during the first 3 hours. Well, that's not an instantaneous rate of change. That's the first 3 hours, and it's a total amount. A, the way you would get A would be 0 to 3 of R of t dt. You would integrate from 0 to 3. That would give you the total amount. And so that is not the answer. That is not what R prime of 3 means. How about B? The amount of change in gallons per hour in the rate at which water is leaking during the 3 hours after the leak is discovered. The amount of change during those 3 hours, that would be the secant slope, the average rate of change. So that is not R prime of 3, which is an instantaneous rate. R prime of 3 is instantaneous rate of change. See, the rate at which water leaks from the tank in gallons per hour 3 hours after the leak is discovered. Well, that's not a rate of change, that's just a rate at a particular point of time. So that would just be R of 3 not r prime of 3. Because the function is the rate, okay? Not the rate of change of rate. And so the answer is going to have to be D, even without looking at it. The rate of change at the rate which water leaks from the tank. So that's it. You know, that check. That's r prime of 3 is D. So read through that. Those are good questions, and those are the kind of questions I can definitely see. This particular AP test, the one in 2020, I can see you getting that kind of question. All right, 78. Says a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to 4 over t cubed plus 1. If the position of the particle is x equals 1 when t is equal to 2, what is the position of the particle when t is equal to 4? Okay, so we need to get the position. We know that at time 2, the position is 1. X is equal to 1. So to get position, you integrate velocity. So plus, and then we're starting at 2. The position is 1 when time is 2, so we need to go from 2 to 4. That'll tell us how far the thing moved of v of t. So of 4 over t cubed plus 1 dt. All right, this part, you put it in your calculator. Go ahead and try that. That's going to be 0.353. So when you add 1 to that, that's 1.353, which is option C. So that's one you could stick in your calculator pretty quick and be all right. All right, let's look at 79. I'm going to draw the graph of 79 real quick. All right, so we got a hole and a point, sharp turn, something like that. Okay, and this is so this is 1, this is 2, and at the bottom there is 3, and the thing finishes up at 4. It says the graph, this is a graph of f. So of the following intervals, on which is f continuous but not differentiable? Okay, so part A, we're looking from 0 to 1. 0 to 1. Well, 0 to 1 is just that right there, and it's continuous, but it's also differentiable. So it's both continuous and differentiable, and it is asking us which is continuous but not differentiable. So it's not A because it is differentiable, right? It's just a line. There's no breaks there. All right, part B, from 1 to 2. All right, 1 to 2, we got a hole. It's not continuous. Okay, so B is not the answer. Part C, from 2 to 3. Well, from 2 to 3, it is continuous, but we got a sharp turn right there. Sharp turn in that interval. So it is continuous, but at the sharp turn, it's not differentiable. So continuous but not differentiable is C. And then D, I'll go ahead and look at D from 3 to 4. You got both. It's not differentiable because you got a big gap, and it's not continuous. So it's neither. So the answer to 79 is C. no calculator required. So just because we're in the calculator section doesn't mean that you're going to be using your calculator every time. I think we've only had to use it once so far. Number 80. Excuse me. First derivative of the function f is defined by f prime of x is equal to x squared plus 1 times the sine of 3x minus 1. And we're worried about the interval negative 1.5 and 1.5. Which of the following intervals is the graph concave up? Well, this is what you need to do. Graph f prime of x. Graph the derivative. Concavity is determined by f double prime. Okay, so you could take the derivative of this and set it to equal and set it equal to 0 and try to do all that, but it's much easier and much faster just to graph that derivative, and it's going to be concave up where the slope of f prime of x is positive. Okay, so if you're reading the graph of a derivative, where the slope is positive is where it's concave up. It's going to be where the slope's negative, it's concave down. So I have no idea if you're going to be able to see this, but I'm going to try to graph, and maybe you can see it. I'll do my best. So let's go to the graph function, and we've got x squared plus 1 times the sine. Oops, need to clear that out. Excuse me. So x squared plus 1 times the sine of 3x minus 1. And let's we'll go to F2 and zoom standard. All right, I don't know if you can see that or not. Okay, so we're only talking about this middle section of the graph. So I am going to, let's zoom in on that, F2, 2 for zoom in, and we'll do it right in the center. You can do this along with me. Okay, so if we want to just move the crosshairs and see where is this thing, the slope is positive. Yeah, I'm moving to the very left. We're only worried about, so the slope is positive. Okay, so it's at negative 1.5 is where we have to start. So that's where the tracker is right there. And the slope stays positive to about negative 1.3. And then if you move on down, you can see that about right there, the slope becomes positive again, so about negative 0.2. And I'll move the target. And then to about 0.9 something, okay? So it's where is the slope of that graph positive? Okay, you can look at it again. Now, hopefully you're following along. And I probably should have drawn, I don't know if you could see that or not, so I'm just going to kind of draw the graph. So that's the graph of the derivative. Okay, and then the slope was positive. It started, we're only going from negative 1.5 to about there, which is negative 1.3 something. and then it starts to become positive here again, which is about negative 0.2, and it goes to about right here, which is like 0.96. Okay, so the answer is A. But the key thing to learn is, okay, if I'm reading the graph of a derivative, what can I tell about concavity? Well, concavity is the second derivative. That's just the slope of the derivative. Where the slope's positive, it'll be concave up. Where it's negative, it'll be concave down. Okay, so you don't want to have to go through all the time of trying to get the derivative of this, setting it equal to 0, getting critical points, doing a sign line, when you can just graph it and interpret the graph. Okay, so 81, I think I can fit here. This is a calculator one. It says during a rainfall, the depth of water in a rain gauge increases at a rate modeled by R of t is equal to 0.5 plus t cosine pi t cubed over 80. Where t is the time in hours since the start of the rainfall and R of t is measured in centimeters per hour. How much did the depth of the water in the rain gauge increase from 0 to 3 hours? How much did it increase? You're tabulating something. You're adding something up. So you're not getting a rate of change. You're not getting a velocity. You're accumulating something. So you're going to integrate. Right? And you're going to integrate that function from 0 to 3. That's the time we want to know about. And that would be just R of t, 0.5 plus t cosine pi t cubed over 80. So I want you to go ahead and put it in your calculator and give that a try. Now, right here where it's between t and cosine, make sure you put a multiplication sign there. All right, I found with the TI-89 it gets confused if you don't do that. All right, so put that multiplication sign there. But what you'll get is 5.401. And that's how much. So that one, if you know what you're doing, really, really quick. Get through that one quick. Okay, let's look at 82. So let f be a function such that f of 1 is equal to negative 2 and f of 5 is equal to 7. Which of the following conditions ensures that f of c is equal to 0 for some value c in the open interval 1 to 5? Okay, let's plot our points. When x is 1, y is negative 2. Okay, that'd be like right here. When x is 5, y is 7. Let's say that's somewhere up here. All right, 5. Okay, and that is 1. Okay, so we know, it may not be a straight line, but we know somehow, we got to get there. Okay, so for part A, it says 1 to 5, f of x dx exists. Well, not necessarily. Okay, that's not necessarily true. There's nothing there that tells us that it does. Part B says f is increasing. Well, we know in general it's going to increase, but maybe not the whole time. What if it goes down first and then comes up? Okay, so it doesn't have to increase the entire way. It could go down before it goes up. Part C is f is continuous. Well, the only way to get to f of c is equal to 0. The only way for it to cross that x-axis, guaranteed, is for it to be continuous at any point. Okay? It's guaranteed to cross the x-axis if the thing is continuous. If it's not, you could have a break there along the x-axis. Okay? And it doesn't say that it's necessarily going to do that. So continuous is the one that will give you a 0. Okay. Part D, F is defined. I mean, you could have holes, you know, along the way, so it's not guaranteed. Just because you have f of 1 is -2 and f of 5 is 7 doesn't mean that you're guaranteed to not have holes along the way. Okay, so the answer to 82 is C. All right, we can do one more and then I'll stop this video. 83. So it says the acceleration of a particle moving along the x-axis is given by a of t is equal to t minus 8 times the sine of t. At what value of t is the particle's velocity, right, decreasing most rapidly? Okay, so what you need to do then is just graph a of t. And see where acceleration is lowest. That's where the speed's decreasing most rapidly. So, all right, let's go to our calculator. All right, I'm going to clear out the one that's there, and we'll do x minus 8 times the sine of x. Oops. Okay, and now we'll F2, and we're worried about between 0 and 8 here, so I'll do F2 6. Okay, I hope that's a good light for you. And you can see that at least between 0 and 8, the lowest point is right there. Right there. So let me trace this thing. So I'm going to hit F3 for trace. And I'm just going to go to the right and see about where it's lowest. And it says here 1.39, and I'm not necessarily at the very, very bottom of it, but I know it's pretty close. And so that's going to be B. That's where acceleration is lowest. You know, on my graph, I traced it 1.39, but it's close enough to 1.42 to know that that's where acceleration is a minimum. At that point, between 0 and 8. Now, I know there's ones that go further south to the left, but that's not between 0 and 8 there. Okay, so that'll do it for this video. Just keep plugging away, keep studying, and we'll see you next time.